So I think this is a good place to talk about smart contracts then. Can you tell me the history of smart contracts and the basic sort of definitions of what is it?
Sure. So I think smart contracts as a definition has actually gone through some kind of changes or small evolution. Initially, I think it was actually a conception of a digital agreement that was tamper-proof and could know things about the world, right? So it could get proof and it could define that something happened and it could conclude an outcome and release payment or do something else. That's actually the definition of smart contracts that I began working in this industry with 7 or 8 years ago when I started making smart contracts. That is the conception that I had of a smart contract. Then what happened was that was really hard to do, right? Building that type of tamper-proof digital agreement that could also know things about the real world and release payments back to people about those events that were codified in this tamper-proof format was actually a very tall order. Turns out it's consistent of three parts. It's consisting of the contract, the proof about what happened, and the release of value. The way things have evolved so far is that the definition has now come to mean on-chain code, right? So it's come to mean the codification of contractual agreement on a blockchain, right? So there's some code somewhere on some blockchain that defines what the agreement is. Now, that eliminates the part of the definition that's related to knowing things about the world, and it partly eliminates the definition about payments and stuff like that. But basically, it's on-chain code, right? We, in our recent work on a second white paper, have actually put out a different definition that we call hybrid smart contracts that actually tries to go back to the initial definition that I started with 7 or 8 years ago, which basically says that there's some proof somewhere that's proven to the contract, and the contract can know that, and the contract can gain proof. Then it can use that proof to settle the agreement that's codified on a blockchain. So you both need a mechanism to provide proof. You need a mechanism to codify the contract in a tamper-proof way on something like a blockchain. And then, as with all contracts, there's a presumption that there's some kind of release of value. So I think a smart contract in our industry right now means on-chain code, which limits it to whatever can be done on-chain only. And then in our internal definition for us, and for us at Chainlink and for me, it's hybrid smart contracts, which is actually the original definition. It's the idea that a contract can both know what happened and automatically resolve to the proper outcome based on what happened.
So you're referring to the Chainlink 2.0 white paper, which is a paper that I recommend people look. It's a very easy read and very well structured and very thorough. So I really enjoyed it. Very recently released, I guess. Can you dig in deeper? What is a hybrid smart contract? You mentioned sort of this idea of data or knowing about the world and on-chain and off-chain. So what are the different roles in this? So hybrid, by the way, refers to the fact that it's on-chain and off-chain contracts. So maybe dig in deeper of what the heck is it and what does it mean to know stuff about the world? From like, how do you actually achieve that?
Yeah, absolutely. So the on-chain part is where the agreement itself is. That's the smart contract itself. And that's where you codify certain conditions, such as the conditions under which an interest payment is made, or the conditions under which the contract pays out the full amount that it holds to someone based on a derivative outcome or something like that. Now, what the on-chain code is very good at is creating transparency about what the core conditions of the contract are. It's very good at taking in money from other private keys that send it tokens and send it value to hold. And then it's also very good at returning money or returning value back to other addresses or other private keys. It can also be involved in governance. It can be involved in a few other private key signature-based operations. But primarily, the on-chain part of a hybrid smart contract, from what I've seen so far, defines the agreement, takes in value, and returns value based upon the conditions codified in the agreement on a blockchain. The second and equally important off-chain part is where the term Oracle and an Oracle comes in, or an Oracle mechanism, or a decentralized Oracle network, as we describe it in the paper. And this is another decentralized computational system that has a different goal, right? So blockchains have the goal of packaging transactions into blocks and connecting them in a cryptographically unique way to create security and assurance about that chain of transactions. Oracles and decentralized Oracle networks achieve consensus and they achieve decentralization about the topic of what happened, right? So blockchains structure transactions. Some of those transactions might be the state changes in different pieces of on-chain code. And then those on-chain pieces of code require input. I think the thing that people get kind of a little bit thrown by is, despite being called smart contracts, the on-chain code on a blockchain cannot actually speak to any other system. So blockchains are valuable and useful as far as they're tamper-proof and secure. And to be tamper-proof and secure, they're made this kind of walled garden that is able to know and interact only with the highly reliable information that's within that system, which is basically tokens and private key signatures. All the other world's information is not available in a blockchain inherently. And a smart contract or a piece of on-chain code can't just say, hey, I'm going to go get some data from over here, because the API they would get it from creates a whole bunch of security concerns for the blockchain itself and a whole bunch of consensus issues about how to agree on what that API said or what the truth of the world is, right? Because it's not even agreeing on what one API said. It's more so creating a reliable form of decentralized computation that can give you a definitive proof of what happened and not just what one API said. So, for example, some of our most widely used networks have well over 30 nodes and well over 10 data sources that are all providing information about the same type of data. And then there's consensus on that one piece of data, which is then written in and essentially given back into the on-chain code to tell it what happened. Because you can't really make an agreement unless you know what happened, right? If you and me were to make an agreement and set some contractual conditions, but our agreement could never know what happened, it would be completely, useless. However, if you and me made an agreement and there was another system called an Oracle mechanism or decentralized Oracle network that proved what happened definitively, and you and me pre-agreed that whatever this mechanism says is what happened, then we can achieve an entirely new level of automation, right? We can suddenly say, there's this piece of on-chain code that's highly reliable. We can give it millions, billions, eventually trillions of dollars in value. And it is controlled by this other system over here that's also highly reliable under this configurable set of definitive truth and decentralization conditions, which we all agree are sufficiently stringent to control that much value. And therefore, the combination of this tamper-proof on-chain representation of a contract and this mutually agreed upon definition of a trigger or a proof system combined is a hybrid smart contract, which, as you can see probably already, does a lot more than just a contract on chain, right?
Can you talk about this consensus mechanism, which, by the way, is just fascinating? So there is the on-chain consensus mechanism of proof of work and proof of stake. And then there is this Oracle network consensus mechanism of what is true. So can you compare the two? Like, how do you achieve that kind of consensus? How do you achieve security in integrating data about the world in a way that's definitively true, in a way that is usefully true, such that we can rely on it in making major agreements that, as you said, involve billions of trillions of dollars?
Right. So this is the challenging question, right? This is the challenging problem that Oracle networks, oracles, we at Chainlink, that we work on in order to create this definitive truth to trigger and create hyper automation in this more advanced form of hybrid smart contracts. The reality, I think, of this problem is that it is very specific to each use case. And this is actually how we've architected our system, is in a very flexible way. So for example, you need an ability for an Oracle network to grow in the amount of nodes that it has relative to the value it secures, right? So if you have an Oracle network that secures $100,000 in like a beta of a financial product, maybe it can be fine with only 7 nodes and only 2 or 3 data sources, right? Because the risk to that Oracle network is relatively low based on the value it secures. So the first question is actually how do you scale security relative to value secured by that Oracle network, because it wouldn't be very efficient to have 1,000 nodes securing $100,000 worth of value. So one of the first questions is, how do we properly scale, and how do we compose ensembles of nodes in a decentralized way where we can know that, okay, we're going from 7 nodes in a network to 15 to 31 to 57 to 105 to 1,000, right? So that's one dimension of the problem.
So you have to be scaling the number of nodes relative to the value that's derived from the truth integrated into those nodes.
Well, that's not the only problem, right? The other side of this is that you're trying to create a deterministic result, a deterministic output from a set of non-deterministic disparate systems, data sources, or places that prove things.
Can you also, just as an aside, what is an Oracle node? What is the role of an Oracle node?
Sure. So an Oracle node essentially exists in both places. It exists in both worlds. It exists as an on-chain contract that represents either an Oracle network or an Oracle node. So there's an on-chain interface in the form of a contract that says, I exist to give you this list of inputs. You can request weather data from me. You can request price data from me. You can ask me to send a payment somewhere.
It's like an API. So it's a pointer to API that that provides truth about this world.
It's an interface. So just like an API is an interface for Web 2.0 engineers, Oracle networks and the contracts that represent them or individual nodes are the interface of Web 3.0's use of services. And services includes all services, data, payment systems, messaging systems, whatever Web 2.0 or any kind of computing service that you can conceptualize needs an interface on chain in the form of a contract that says, here are the services I can provide for you. Here are the transactions you need to send me to get back this data or that computation or this result. And then what you actually see is that decentralized Oracle networks, because they're uniquely capable of generating their own computations in a decentralized way around the data that they have access to, you actually see decentralized Oracle networks generating a lot of these services. So for example, we have a randomness service, a verifiable randomness function service that basically provides randomness on chain. And that randomness is then used in lotteries and various other contracts that need randomness. But that randomness, it's not a piece of data that comes from somewhere else. We don't go to another data source and get it. We generate it within an Oracle node that then provides it over into Oracle node or Oracle nodes that provide it into the contracts themselves.
So why do you say Oracle nodes are non-deterministic?
Well, they are as far as they come to consensus, but see, there's this kind of different problem here, right? The blockchains are very focused on generating blocks of transactions within a smaller universe of transaction types, a certain block size, and a certain set of conditions. And then they have a economic system that says, I will perpetually generate blocks of this size with these transaction types in this kind of limited set of transaction types, whether those are UTXO transactions or scripted, Solidity, or whatever it is. Oracles and Oracle networks, we don't have a blockchain, for example. There is no Chainlink blockchain. Our goal is not to generate a certain set of very clearly predetermined transaction types into a set of transactions that are put into blocks, and it will infinitely be done that way. Our goal is actually to create what we call a meta layer, a decentralized meta layer between the non-deterministic, highly unreliable world and the highly hyper-reliable world of blockchains, so that the unreliable world can be passed through this decentralized meta layer.
And it can coexist with the reliable on-chain world.
Exactly. It can coexist, and in some cases, the meta layer might generate it. So the problem in giving you this straight answer is that there's just such a wide array of services. Right. If you were to say, well, Sergey, how do we generate randomness from a data source? Well, we don't use a data source to generate the randomness. That's the type of service that can be generated in an Oracle network itself. And so there will be certain computations that Oracle networks themselves generate themselves to augment and improve blockchains.
Got it.
And it is actually the goal of Oracles to consistently do that. So if you were to think about the stack in a very generic high level, you would see blockchains are databases. They're basically the data structures that retain a lot of information in this transparent, highly reliable form. Smart contract code is the application logic. It is the logic under which all of this kind of activity occurs. Storing data in the data structure in the blockchain as a database in a certain conceptualization of it. And then oracles and oracle networks are all the services that are used by the application code. So, by analogy, let's take Uber. Uber initially, some core code goes and gets the GPS API from Google Maps about the user's location, sends a message to the user through Twilio, pays the driver through Stripe. If those services weren't available to the people who made Uber, they wouldn't have made Uber, right? Because they would have written their core code on some database, and then they would have had to make a geolocation company, a telecom messaging company, and a global payments company. And they wouldn't have done that because it's too hard. And that's the weird scenario that a lot of people in our industry are in. And that's the problem that oracles and oracle networks fix, is they provide these decentralized services to take this developer ecosystem, the blockchain and smart contract developer ecosystem, from, hey, I can have a database and write some application logic about tokenization and voting and private key signing, all of which is super useful and is a critical foundation. But now, if you just layer on all the world's services, whether that's market data, weather data, randomness, suddenly people can build DeFi, fraud-proof gaming, fraud-proof global trade, fraud-proof ad networks. And that's why this world of decentralized services and decentralized oracle networks is particularly, in my opinion, important to our industry.